Imagine standing before a blank canvas where a standard rectangle transforms into an elegant geometric puzzle. The base spans 20 units, and the height is strictly 3/4 of that length, tracking cleanly at 15 units. The diagonal acts as a structural fault line, splitting the rectangle perfectly into two right-angled triangles. Our eyes focus strictly on the lower left half, where a perfect circle is nestled snugly inside, kissing all three sides. Deep in the upper right corner of the main frame, a smaller rectangle emerges, anchored at one end by the center of that inscribed circle and stretching its boundaries to meet the outer vertex. The secret to cracking this open lies in recognizing that the right triangle is a beautifully scaled version of the classic 3-4-5 triplet. Because the legs are 15 and 20, a quick trip through the Pythagorean theorem reveals the diagonal hypotenuse is exactly 25. Your first big breakthrough hinges on finding the size of that inner circle. Remember that for any right triangle, the radius of its inscribed circle can be calculated by summing the two legs, subtracting the hypotenuse, and having the result. This specific radius dictates the exact spatial address of the center, because it is shifted inward by that exact amount from the outer walls. While plugging the numbers into our toolkit, the math unfurls beautifully. The leg sum minus the hypotenuse leaves 10, which when halved maps the inner radius at exactly 5 units. This means the center sits exactly 5 units away from both the bottom and left borders. To find the dimensions of our smaller target rectangle, we look at how much room is left to reach the far corner. The width is the total width minus our horizontal shift, leaving 15, and its height is the total height minus our vertical shift, leaving 10. Multiplying these remaining gaps together yields a final, satisfying area of exactly 150 square units.